We are going to be looking at solving rational equations, which is in lesson 11.5. So if you do have your guided note packets with you before you left for the weekend, then you can get those out. You can go to this section and then you can already follow along in your guided note packets. If you don't, feel free to write it down on a separate sheet of paper, or you can just follow along with the video and then try some practice problems afterwards. So let's talk about the steps for solving rational equations. To solve rational equations, the first thing we're going to want to do is figure out what the least common denominator is, or the LCD. So when we're talking about an equation, we could be adding or subtracting. It's set equal to something, but we're dealing with fractions. And in order to add or subtract fractions, you have to have a common denominator. So that's why we have to find the LCD first. Once we find that LCD, we're going to multiply every single term in the equation by that LCD. Regardless if your original equation has every single term with a fraction, we do multiply every single term by the least common denominator. When we do that, we will then have created an equation that should not have any fractions. So if you end up with an equation that after you multiply still has a fraction, we made a mistake with finding our least common denominator, so you'll have to go back to square one and try again. But by solving the equation, it could be a one-step equation or a two-step equation. We want to solve for the variable. And then our final step is just making sure that you are checking your solution. Because we will have variables in our denominators from time to time, we never want our denominator to end up as 0. So the moment we check our work, if we get a 0 in our denominator, that number that we got cannot be our answer. So it is very, very crucial that we check. Let's go ahead and look at this first example. Say I wanted us to solve the equation 5 over 12 minus 1 over 2x equals 1 over 3x. And then once again, we have to check the solution. So our first step is figuring out what our least common denominator is. So looking at our denominators, there's 3 of them. Everything here is a monomial, so that's pretty nice. So when we have all these monomials, the first thing I'm going to look for is what's the first number that they have in common. So because there is a 12, a 2, and a 3, I have to look through all of those multiples, and I have to figure out what the first multiple that they have in common is. So if I kind of go through my multiplication charts, 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, and so on and so forth. 2, well, 1 times 2 is 2, 2 times 2 is, oops, not 3, 2 times 2 is 4, 2 times 3 is 6, then 8, then 10, then 12, and so on and so forth. 3, well, 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, and so on and so forth. Notice how with these lists of numbers, I'm looking for the first number that they have in common. That number ends up being 12. So I know that 12 is going to be a part of my least common denominator. When there are variables in my denominator, I'm looking to see, are they the same letter? In this case, both of them are an X, so that's good. Remember, when you have the same variable, you want the biggest exponent. They both have the same exponent. They technically have an exponent of a 1. So if their exponent is the same, we only have to write that X then one time. So if they're exactly the same, write it once. Now that I have this least common denominator, I'm going to multiply the entire equation by it. So 12x is going to get multiplied by 5 over 12. I'll bring down that subtraction sign. 12x has to get multiplied by 1 over 2x. Bring down the equal sign. 12x has to get multiplied by 1 over 3x. Usually you'd have a yellow calculator to help you out. If you don't have a calculator available, you should be able to still use your calculator on your phone to complete this. So one way to think about this is I can always put my least common denominator over the number 1, and we multiply fractions straight across. So in this first term, I'm going to multiply the numbers on the top together. 12 times 5 Well, that's 60. There was an x with it, so I'm going to keep an x on the top. And then on the bottom, 1 times 12 is 12. Bring down the subtraction sign, multiplying straight across. 12 times 1 is 12. There was an x on the top, so an x stays on the top. On the bottom, 1 times 2 is 2. There was an x on the bottom, so I have an x on the bottom. That equals, when I multiply straight across, 12 times 1 is 12. There was an x on the top. 1 times 3 is 3. There was an x on the bottom. We now have the multiplication taken care of, but since everything's a fraction, now we have to think division. 60 divided by 12, well, that's 5. There was still an x, so I still have an x with it. Bring down the subtraction sign. 12 divided by 2 is 6. Notice how there's an x on both the top and the bottom. Those cancel out. There's no more x's. That equals 12 divided by 3 is 4. X divided by x, because there's an x on the top and the bottom, there is no more x, so 4 is the only thing left there. And so notice that we did pick the correct least common denominator because now my equation has no fractions. Our last step here then, we got to solve for x. So since there's two numbers on the same side as x, I'm going to add the 6 over to the other side. That still leaves me with the 5x. 4 plus 6 is 10. I'll divide both sides by 5, and I'll get a possible answer of x equaling 2. I'm not saying it's my final answer until I've checked my solution. So I go back to the original problem. Anywhere that there is an x, I'm going to substitute in the number 2. Well, the first fraction didn't have any x's. If I look at the second fraction, hey, there was an x in the denominator. I'm replacing it with a 2. On the third term, there was an x in the denominator. I replace it with a 2. And remember, your goal is just to look at your denominators. I never want them to turn into a 0. Well, 12, that won't turn into 0. 2 times 2, that's 4. That's not 0. 3 times 2, that's 6. So none are 0, which is exactly what I want. And so because none are 0, that means my answer checks out. And so x equals 2. If we take a look at the next example, 4 over 7x plus 1 over 3 equals 7 over 3x. We have to find a common denominator, so I'm looking for a least common denominator first. With my denominators all being monomials, I'm going to start with the numbers. So notice that there's 7 and there's 3. So if you go through your list, 7 and 3, you'll see that the first number that they have in common is 21. When I look at my variables, x and x, because they're the exact same, I only need to put that x once. So hopefully 21x is that least common denominator. We'll know if we have it correct if when I multiply that by everything in my equation, I have no more fractions. So notice 21x times 4 over 7x. I brought down the addition sign. 21x is now getting multiplied by 1/3. Bring down the equal sign. 21x is now getting multiplied by 7 over 3x. So once again, think of that as 21 over x. I'm going to multiply straight across. 21 times 4 is 84. There was an x on the top. On the bottom, 1 times 7 is 7. There's an x on the bottom. Bring down the addition sign. 21 times 1 is 21. There was an x on the top. 1 times 3 means that there's 3 on the bottom. Bring down my equal sign. 21 times 7 is 147. There's an x on the top. 1 times 3 is 3. There's an x on the bottom. So now I want to do my division, and I'm looking to see, can I get rid of my fractions? So 84 divided by 7 is 12. Remember, because there's an x on the top and the bottom, that goes away. Bring down the addition sign. 21 divided by 3 is 7. There's only an x on the top, so that x has to stay in my problem. That is going to equal 147 divided by 3 is 49. There's an x on the top and the bottom. Those divide away. So now here's my equation. 12 plus 7x equals 49. There is no more fraction. We know that our LCD is good. So now I'm going to start solving. I'm going to subtract I'm going to subtract 12 from both sides. Still gives me 7x on the left. 49 minus 12 is going to give us 37. I'll divide both sides by 37. And now 37 and 7 don't divide nicely. They don't reduce down any further. So I'm going to leave it as that fraction. It's okay that my final answer is potentially a fraction, but I just didn't want any fractions when I was actually solving for x. But I'm not going to circle that until I check my answer. So I go back to my original problem. We had 4 over 7 times x, but I'm going to replace x with that fraction. Plus, then we have 1/3. There were no x's in there. My last part, it's going to equal 7 over 3 times, then I'm replacing x with that fraction. Remember, I just never want 0 in my denominator. If I look at this first denominator, when I multiply a positive times a positive, that's not going to turn to 0, so that's good. 3, not going to turn to 0. Over here, those two numbers, positive times a positive, not going to turn to 0. So once again, none are 0, which is what we want. And so even though it's a fraction, that's okay. This is my answer. Last example together. If I want to solve 2 over 5x minus 1 over 2x equals -1/2, we have to find our least common denominator first. Looking at the denominators, they're all monomials. So let's start with the numbers. I've got a 5 and a 2. So if you look through all of the factors and multiples of 5 and 2, the first number that they have in common is 10. Looking at the variables, they have the exact same letter and the exponent is the same. So I just have to write that once. So 10x is my LCD. So now I'm going to multiply 10x by everything in this equation. Notice that I'm bringing down the subtraction sign as I continue this. Now, on the other side, I want you to notice that the negative is only going to go with one of those numbers. It doesn't matter if you keep it with the top or the bottom. I usually keep it with the number on the top. So -1/2 is the same thing as -1 over 2. Think of that 10x as over 1, and we can multiply fractions straight across. 10 times 2 is 20, and there's an x with it. On the bottom, 1 times 5 is 5, and there's also an x there. Bring down the subtraction sign. 10 times 1 is 10, there was an x on the top. 1 times 2 is 2, there was an x on the bottom. That equals 10 times -1 is -10, there's an x on the top. 1 times 2 is 2. Now I'm going to divide everything. 20 divided by 5 is 4. Those x's cancel out. Minus 10 divided by 2 is 5. Those x's cancel out. On the other side, -10 divided by 2 is -5, and I have to keep the x because there was only one x on the top. To start solving for x, notice the left side has like terms. 4 minus 5 is -1. The only thing I have to do to get x by itself is divide by -5. A negative divided by a negative is a positive. 1 over 5 is going to be my potential answer. I can't reduce down that fraction any further. But I'm going to check to make sure that it works. I never want 0 in my denominator. So when I start replacing x's with 1/5, we'll make sure to see if our denominator is 0. All right, 5 times 1/5, a positive times a positive. That will not turn to 0. Next denominator, 2 times 1/5, a positive times a positive. Not going to turn to 0. This denominator is 2. That's not going to turn to 0. So none are 0. And even though our answer is a fraction, that's okay. X equals 1/5. So now that you've seen these 3 examples, I would like you to try this checkpoint problem. So solve the equation, check your solution.